Here it is, the overtone series. Every string on the piano makes a complex sound called the overtone series. The overtones are higher frequencies blended into the whole sound of the string. Musical harmony is based on these overtones, and piano tuning arranges these overtones into a beautiful lattice work of sound. This pattern is the same for every note on the piano, and to understand tuning, you will need to know the overtone series of every note of the chromatic scale. You can use the C overtone series to make a set of overtone cards. In this course, you'll use these cards to find all the overtone connections in a tuned piano. Eventually, you'll know the overtones of all notes whenever you need them. Your facilitator helped you to make a set of cards. In tuning language, we call these overtones partials, since each is a part of the whole sound, and identify them as the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th partials. Use these cards to practice sounding the overtones of notes all over the piano. We've all heard about beats, and we've all struggled to hear them. Is it my ears? Is it my brain? Seems like everybody else is hearing beats, but why can't I hear them? In theory, beats are very simple. When two close but not quite identical frequencies are played together, they produce a repeating interference pattern that we call beats. The sound gets a little louder, gets a little quieter, gets a little louder, gets a little quieter, gets a little louder, gets a little quieter. Very simple. Well, very simple when the sounds are sine waves. Sine waves don't have overtones. For example, we're going to listen to some sine waves. I think you know the mathematics of it. 220 hertz, 224 hertz will beat 4 times a second. 224, 22 hertz, twice a second. 222 and 220, twice a second, and so on. Listen to the pattern here as I divide the difference between the two frequencies. Each step of the way, we'll have equally beating intervals. But sine waves are simple sounds that don't have overtones. Their beats are simple. Listen to what happens when I do the same thing on the piano. Piano unisons have multiple common partials. An out-of-tune unison produces beats on many levels. They compete for our attention. Higher level beats beat faster than lower level beats, and as we narrow the difference between the two strings, low beats will become softer and higher beats become more prominent. Sometimes the sound just seems to get dirty or wobbly. Beats phase in and out as the vibrating strings give up their energy over time. Now, before you begin this exercise, cut yourself some slack. Those perfect beat rates that I tuned on the piano were a way to communicate the exercise. And to tell the truth, I used CyberTuner to get them that accurate. Getting precise frequencies is not the point of this exercise. The point of the exercise is to practice making equal beat rates by splitting the difference between the left and right strings. Start the exercise with a beat rate you can hear, then try to slow it down by half. Then compare both sides of the unison. If they're equal beating, you're amazing. If they're not equal beating, then try to even them out. And then try to slow that beat down by half. You can put your overtone scale card on the keyboard and see how many partial beats you can hear as you narrow the differences. Higher partials will beat faster than the lower ones, and that's good because they'll help you make finer judgments. This is a profoundly difficult exercise. Do your best and let go of judgments and outcomes. Do it for the sake of learning. Fine-tuners struggle with unisons for a lifetime.